All right, ladies and gentlemen, let's talk about factoring. Now, there are two big things that we have done in this chapter. Actually, one that we've done and one that we're going to do. One is the multiplication of polynomials. So we started by simply taking one little piece of monomial, giving it away to everything. Then we took polynomials here, polynomial here. We said give away the first part, each piece, give away the second part, each piece, give away the third part, each piece. Okay, we did all that. Then we did some special products, binomial by binomial, FOIL, all that stuff. So thus far, this chapter, we've been taking two things and we've been putting them together. Now what we're going to do is instead of putting things together, what we're going to do is take stuff that is together and we're going to start peeling it apart and breaking them up, okay? That's what we're going to do. That's what factoring is. In its base, let's start with this example. If I said 12, I said, what are the factors of 12? You could tell me 2 and 6, or maybe if you had 12, you said 3 and 4. Or maybe you said for 12, it's 1 and 12. In either case, this times this should always equal 12. This times this should equal 12. This times this should equal 12. What we're doing is we're breaking it into pieces that we can multiply back together to get the original thing. So we're taking something and we're breaking it apart, okay? Now, if I were doing something like this, 6x parentheses 4x squared plus 2y x plus 3y. And we were to multiply it out, we said give it away, give it away, give it away. So we said 24x cubed. Now, by the way, do you notice that we keep doing the same type of problems over and over and over again? I keep asking you to learn them. Please learn them. Okay? Plus, now we get 12, but I don't have any other y, so it's just y. Now remember, this is x to the first, that's x to the first, so it's x squared, and then plus 3. Oh, I almost did it. What did I forget to do? 6 times 3 is 18xy. 18xy. There we go. So I gave it away and put it together. But let's say I don't want to do that. Let's say instead of being given this and I'm supposed to give it away, I'm given this. And it says factor. Break it up. What times what made this? Well, there's a lot of things that, just like the 12, it could have been lots of different combinations made that. But what I can at least say is I can say, okay, looking at these numbers, 24, 12, and 18, I can take out a 2. Well, wait a minute, I could do better than a 2. I could take out a 6, because 6 goes in here, here, and here. So we're taking out the greatest common factor, the GCF. So the greatest common factor of numbers is 6. Now, that leaves 4, that leaves 2, and that leaves 3. Now, let's take out all the x's I can. I got 3 x's here, that's cool, but I have only 2 x's here and only 1 x here. So if I have to take them away evenly, I'm going to take 1 x out of each, because although I could get 3 out of here, I can only get 1 out of here. So it's 6x, leaving, well, if I have 3 x's, I take away 1, I'm left with 2. If I have a y, well, I haven't even touched y's. And if I had 2 x's, but I took out 1, I'm left with 1x. Finally, over here, this 1x goes away, leaving just y. What signs go between them? Whatever signs were between them before. So what I've done is I've taken out the greatest common factor. Now, some people get all excited and they say, well, that means you took out x cubed because you took out 1 here, and 1 here. No, you only took 1 from each. You only took 1/6 from each, just like when you put it together the first time, you gave one of them to 3 different pieces. Okay? So you'll notice that indeed we get right back where we started. So this is multiplication by distribution. This is factoring by distribution, or greatest common factor. That's what we're going to be doing here. So let's do another one for greatest common factor. If I have 27y squared plus 18y, what is the biggest thing that I can take out of 27y squared plus 18y? All right, that's going to be a y and a 9. Leaving, well, what's 27 take away 9? That's 3. What's y squared take away y? That's 1y. Plus, that's going to be 2 with no y's left over, and there you go. Now, obviously, how can you check to make sure you have the right answer? Well, you can check to make sure you have the right answer by giving it away. You can distribute again and see, does it go back to being the original thing? And the answer is yes, it does. So that is factoring by distribution. Okay, factoring by distribution. So that's nice. And it'll work with 3 pieces. It'll work with 2 pieces. It'll work with tons of pieces. But we're not even going to mess really with that. So what we're going to do is let's go ahead and do another one. In this case, I have 4QR plus 8R plus 3Q plus 6. Okay, now, in this case, let's see what we can take out. Well, 4, maybe a 4 or a 2, maybe a 4 or a 2, but I can't take a 2 out of 3. I can't do it because remember, we're dividing. Okay. So what about if we take out a Q? Q comes out of here. Q comes out of here, but I got no Q here or here. Same thing with R. Here's a hint. With 4 pieces, 1, 2, 3, 4, sometimes there's this cute little trick that you need to know. Instead of dealing with the whole problem all together as one like I did here, let's break it up into a 2-part problem and a 2-part problem. What could I take out of here? The answer is a 4 and an R. So if I take a 4 and an R out of there, I'm left with pretty much a Q. If I take a 4 and an R out of here, I'm left with, be careful, the answer is 2, because we're not subtracting, we're dividing, because if I were to put it back, 4RQ, 8R. There you go. So if I were to put it back, it would go right back where it should. Now let's deal with this one. What can I take out of here? Well, I can take a 3 out, leaving Q plus 2. Now, you'll begin to notice the trick. If you haven't noticed it yet, take a look at what I have left. Do you see anything that might be useful? In this case, we have a greatest common factor. And that is, do I have a Q2 or a Q plus 2 in this part and a Q plus 2 in this part? I do. So could I take the Q plus 2 out front? Leaving what's left if I take a Q plus 2 out? 4R. What's left over here? Plus 3. And so by working these together, I actually have simplified this way, way down. Now you say, well, I don't think it's the same anymore. Well, let's try it. Take this times this, and I get 4R times Q plus 2. And if I take this times this, I get plus 3 times Q plus 2. And if I give that away, I get 4RQ plus 8R plus 3Q plus 6. And does that match the beginning? Absolutely it does. There goes another marker, by the way. It absolutely does. But we don't want to take it apart just to put it back together. That'd be silly, taking it apart just to put it back together. We want to start here, and our answer would be that guy right there. So let's do another one of those 4-parters where we're distributing, but it's called distributing by grouping. Distributing factor by grouping. So let's do another one here. Let's go 2mk minus 12m plus 42 minus 7k. I'm warning you there's a second trick in this one, but let's see if we can get it started. I always ask myself, what do I do? Can I do anything across the board? Take out a 2, take out a 2, take out a 2. Oh, crap. Okay, take out a k. No, I can't take out a k. Take out an m, take out an m. Oh, crap. Okay, I can't do that either. So, in this case, it's a 4-parter. So let's take these 2 parts and these 2 parts and see what we can do. If I have just those 2 parts, what can I take out? 2m, leaving k minus 6, because I take 2 out of 12, I get 6. Take the m away, I get that. Now over here, what can I take out of just those two? 42 and 7. Well, I can take 7 out, and that leaves me 6 minus k. Well, that's cool. Oh, wait a minute. Over here, I had q plus 2, q plus 2. They were the same. I was able to pull them out. Here, I don't have the same exact thing. They're backwards of each other. Now, what if I took out a negative 7? Well, that means negative 7 out of negative 42 is negative 6. And negative 7 out of negative 7k is positive k. Is that the same? The answer is yes. So if you get something that is the same numbers, but exactly turned around negative each other, take out the negative, not just the regular 7. And now can I take k minus 6 out, leaving 2m minus 7. If you don't believe me, let's put them back together real quickly. K times 2m minus 7 minus 6 times 2m minus 7. So I have 2km minus 7k minus 12m plus 42. Positive 42, negative 12m, negative 7k, 2mk. I agree, it does work, so that's all good. There's my answer. So that's factoring by grouping, even with additive inverses. So here's what I want you to do. I want you to do a couple practice problems for me. One, I have 6x cubed plus 3x squared plus 9x. I want you to factor. Number two, I have 15x cubed y plus 5x squared y squared plus 10xy. There you go. So let's see if we can do that. And finally, number three, I have 16x squared plus 4x, and I have 8x plus 2. See if you can break that up by splitting them into 2 pieces and 2 pieces. Hopefully, if I did it right, it's going to work. So, 1, 2, 3, see if you can do those for homework.